This is an error code 53 on a Hitachi VRF. There's plenty going on here, like double fan. Anyway, so we'll go through checking that inverter out. The gist of it is, there's our main board. Zoom out, there you go. Inverter's behind here. So 3-phase going in, inverter output, and positive and neutral, a couple of other bits in there. A couple of fuses up there, you can see them. One of those, or maybe two, feed down to here. Yeah, I just tried it on a test run, which is this little dip switch up here. Test run cooling. Not much happened, and then 53 popped up, which was a complaint anyway. So first off, we'll check P and N, positive and neutral. We got that. Check the power supply. Check the compressor. Then we can do inverter tests on the module. Sounds fun, doesn't it? Perfect for a Saturday morning. Where else would you rather be? Right, let's go. Alright, meter's wedged in there. It's a bit awkward one-handed, but in we go. We'll do the P and EN. Those two up there, they're the two in the middle. Might get them the wrong way round. Doesn't matter. Right, 468 volts. So we got DC voltage going to it. Just to double bag it, we can check 3-phase between these two. 412. Next one. 412. And the last two. 411. If you're being extra keen as well, always good, especially when you first power these things up. Anything 3-phase. Check, well, it's a bit late now because it's been on all night, but check you've got a decent neutral there as well, which there is, because if you lose your neutral through the isolator, if it's switched, all hell breaks loose. Yeah, a few balls popped. So anyway, that's all good. So next up, we've got the right power supplies to the module, so we'll do the compressor checks and do the inverter checks. Right, excuse the bodgery. Megger. General rule of thumb is, whatever you're working on, voltage wise, it's twice the voltage that you check it at. So this is 3-phase. So as a rule, 1000 volts megger. Anything above 10 mega ohms is what we want. I got it set on full whack there. Bodgery. There you go. I got it on the earth there. That's only better. I could go on with, so I could go with a spare hand, and then just go on to one of the phases, as long as it's over 10 mega ohms. 488. You can go on the others there, that's the next phase, but unless there's a winding broken, you know, you get a reading, the same reading really. So mega's good, nothing down to earth. And if we want, we can check, let's get it out of there, we can check the windings. They're going to be low. There we go, right. 2.1 ohms. Next phase is same, 2.1, and between the last two, 2.1. I thought it was going to be 4 for a minute there, could have been exciting. No, 2 ohms each. So compressor isn't down to earth, and the windings aren't burnt out. Could be seized, but static checks, all good. Next up, the exciting bit. Let's go diode testing of the inverter module. Right, diode test, pretty easy in principle. You need to find your compressor output, which we know is lurking in there, and the P and the N, positive and neutral, which, look at that, P and N. Even an idiot like me can figure this one out. Smaller boards, it's all part of, you know, a board that does everything else as well, so you have to hunt around on the board. If you can find a chunky capacitor, that's a P&NN, lovely. And this one's got some more, oh, you can't see, there's a couple more lurked in there as well. But anyway, check a wiring diagram, love a wiring diagram. That'll show you where the P and the N's are sometimes, but like I say, if it's just a single board, you've got them small splits, then you're on your own, just use your skills. Anyway, so what I'm going to do is, we've got a red and a black, and I've got my test meter on diode. See the diode symbol. So I'm going to put a red lead on P, and then I'm going to do my black lead on each of the inverters. Why is that away? On each of the inverter outputs. So red lead on P, and I'll go black one, black one, black one, and I'll get 3 readings. Then I'll do my red lead on N. You see where this is going? Black, black, black. Then I'm going to swap them round. I'm going to put my black lead on P, and I'm going to go read, 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 and I do my black lead on N. And another 3 readings. I'll have 12 readings. They'll either be, they'll be in groups of 3 obviously, and they'll be reading open circuit, or generally 0.4 volts, something like that. Let's just get this balanced. Right, so you won't see me touching it on the terminals because I've not got enough hands, but I've got my red lead on P, and I got my black lead go down the bottom. Open circuit. Okay, open circuit. So this one should be open circuit. What? 0.096. Well, that's at it. So that means that the transistor on this leg somewhere, and there's 6 of them in there, it's gone doolally. But let's just carry on, see what else we got, just because we're here. So I've got the red lead on N, and same thing. There we go, 0.4. See that a lot. 0.4, 0.4, 0.4. So between neutral and this one, it's all right, but positive in this one, goosed. Right, so let's swap them over. Black lead up the top on P. Can I have a P, please, Bob? Right, down the bottom. 0.4. Here we go, 0.4. Now this will be interesting. Well, sort of, is to me. What we got here? 0.096, goosed, isn't it? And then we go between neutral. Go on you go. Into the open circuit. Open circuit. Open circuit. Good. So what have we proved? Inverter board's knackered. Compressor electrically is good. Compressor could be seized, couldn't it? We can't prove that until we can get it to run up. We need an inverter board for that. So next step, inverter board. Who doesn't carry a spare inverter board with them, eh? Come on. Of course, we always carry a spare inverter board. Look at this one. They even give you the heatsink paste. Wonders will never cease. These are Hitachi boards. I believe when they first made them, they weren't quite man enough for the job, which is why they pack up. So I kind of knew what I was getting into when I came here today. But they also changed these resistors for a bit of a different reading as well. This isn't the first time this unit's had a board on it. So I suppose we'll change these anyway. We've got them, haven't we? So 2 resistors and come on. One inverter. Well, sorry, this is painful for you watching, isn't it? Come on, man, get it out of the box. There she blows. Bit of a beast. Heat sink for the back. Yeah, they changed the design. One Hitachi guy told me that yeah, they're all good now. They can take the current going through. They don't go pop. So I ended up changing one that I'd already changed for a new type, you know, a couple of years later. I spoke to another Hitachi guy. He says, well, yeah, that was the story. They were beefed up, but yeah, they're not great. Still the same. So I don't know who to believe, to be honest. If you've got power supply issues, can be another issue. But you can see on this one, see, it's got hot. Don't know if you can see on the bottom of the inverter along here, you can see like a shiny oily substance. So it gets hot, something leaks out. You see the heatsink stuff's dribbled out a bit. I've had it on thick paste, thin paste, I don't know. Still seems to do it. You might take the box off, maybe see if the air vents are blocked up, but well, the fins are at the back, aren't they? Anyway, we'll get this on. We'll sort out the resistors out the back as well, why not? And then we'll just check that the airflow's good. Alright, new board is in. So you want to clean all the old heatsink paste off. Don't just use the stuff that's there. New stuff. An electronics guy once told me, instead of squadging it on with your thumb, just get a Stanley knife blade and just put a bit on and then just scrape it across so you get a thin layer. So I don't know, he knows more about electronics than me. So that's in, that's all good. What else have we done? There's a capacitor here. Don't know what it should be. Nothing marked on it. Had it off, nothing there. That's reading 1.7 millifarads, probably about right. And then here we go inside, this bit comes off. And then in here, there's two more capacitors, 3 millifarads for those two. There's the two resistors. I mean, the old ones weren't that old anyway, but anyway, they're in. You've got a contactor there as well. It's not shorting across, it's not stuck on. And you can normally, if you want to, you can't really check it when it's running, it's a bit awkward. Well, I suppose you could here, but you can measure that coil, normally like 1500 kilo ohms. Sorry, 1.5 kilo ohms. Yeah, 1500 ohms, so that's that. The wiring, a little bit confusing. A little bit confusing as to how this particular inverter goes, but there's your inverter board, obviously. Compressor out, 3-phase in. I'm not sure what that 3-phase is in for. There must be a diode block in there somewhere. Yeah, of course there is. So 3-phase in. And I guess it comes out on P1 through that contactor, through the reactor, which is that big beastie there, that big weapon, and then back in. But also when it charges up the capacitors, it goes through those resistors just so it doesn't take a great big chunk of current straight away. So confusing. That C1 is just the tiddler. This one, 47 microfarads. I guess that just stops noise. I don't know. Anyway, that's of course P and N, which are the two in the middle. That's the P and the N. So there's that one, and then there's the two big ones, CB1, CB2. There's a third one there somewhere, isn't there? Not sure, maybe, oh there it is, CB3. Ah, so that one's for the fan motor. Oh, bonus, check that as well. Okay, so, next up, let's just hang the electrics off, shall we? See if there's any dust in these holes, because they're not set up for the airflow. You've got holes there, but underneath is all solid, so there's a little bit of sort of a duct arrangement that, so I suppose it's to stop too much fluff getting in there, but we'll hang it off, see what we can do. Right, we are ready for the big switch on. Starting to rain halfway through. Got my umbrella up. Right, just by the by, if you want to run these up, if let's say inverter tested all right, what you can do on these are pretty good. If you do the dip switch, number 1, turn it on, it's off at the moment, turn it on, and that stops this board reporting back how much current it's taking or if there's a fault with the current it's taking. So you turn the dip switch on, obviously this is with it all powered off, take the compressor terminals off, turn it on, put it into test run, then it should be trying to fire this up and you can check if you've got an output. So you're looking at a balanced output between the phases. No proper reading that you'll ever be given, but a balanced output, like 50, 100 volts maybe, it'll flick up and down a bit. And then you can see if it's not under any lows, it's not proving it definitively, but you can kind of prove you get an output from here. We don't need to do that because this one had 40 diode, 40 transistor, didn't it? So that was that. There's the ducts. I tried to take the electrics off, that didn't go to plan, it started raining halfway through, but these ducts up here, Lord, there it is, sort of pulls down, blown them through. There's one there somewhere underneath all that inverter gubbins, and then the heatsink up, well, is it the fins you get down from underneath here somewhere. Anyway, it's all blown through. Cut a long story short, powered it back up, taking the isolator apart. The neutral is switched, proceed with caution, and it's looking pretty manky, so I would have swapped the neutral onto the little bar that you can connect them to, but it's quite chunky cable and it's only a tiddly thing, so you know, not going to sod around with that, that's not what we're here for. So we're all on. Test run, cooling is dip switch 4, is it? Number 1 on. Right. And these are pretty good because these systems might not come out too well depending on how well it flashes, but you can hold this in and you get a whole load of readings. All a little click. Don't know what everyone means off the top of my head. CC. No, I don't. I know the important ones I need to know. PD, pressure discharge. Come on, pressure discharge. That's 10 bar. And pressure suction, 0.88. So we know we've got refrigerant. Hang on, rain's coming. So that's good. One of these is, I don't know which one it was, compressor hertz. Compressor output. And you would see, if you had it in test run, the compressor hertz would be, I don't know, 30 hertz. And then you would see a corresponding output. If that was on 0 hertz and 0 output, well, that's why you're not reading anything. Also, you've got indoor liquid line for number 3. I think there's 3 units on this. Gas line 1, gas line for unit 2, gas line for unit 3. So they're pretty good. You can see everything running. I can hold that in just to come back off. So let's wait for something to happen. Hopefully not error code 53. Right, the beast is back from a long sleep. So what have we got? There's your, right, it's all screwed back together now. Inverter's in there. Kind of pointless taking a reading from there because that's going to the compressor, but it changes up and down. But we've got 7 odd amps on each one, so that's good. I've had it in cooling, which is our dip switches, wasn't it? There are 2 of them up for heating, and these are pretty good, like I was crapping on about earlier, because you can go through readings, and I believe it is HI is for the compressor frequency, which is 62, and yeah, I think CC is the number of compressors running, which is 3, which I think that's right, because we've got the inverter one running, and there's the contactors, and these 2 top ones are in, and that one's off. 4 compressors in this one. What a beast. Anyhow, enough of that. we have we can get the pressures up here as well. Discharge pressure 30 bar, lovely. Suction pressure 7 bar, even better. Discharges, if they're over 100 or getting up that way, you're in a bit of trouble. But these are all, look at that, in the 70s, 69. And then we can go through to the indoor units. Expansion valve 1, we're in heating, don't forget, so that's open 100%. There's 3 units we got here, so number 2 is 47%. All right, that threw me. Let's go with it. Indoor 3 is 100. Okay, well, all right, fair enough. So liquid line, so this is coming out, so there's hot gas going in and a warm liquid coming out. 47 degrees, 48 degrees and 46 degrees. Now the hot gas coming in, remember it's coming off the compressor discharge in the 70s, so the gas line going in, 65 degrees in, 65 degrees in and 63 in. Don't know why that expansion valve was closed a little bit halfway, but oh, there you go. Inlet, air in, 25 degrees, 23 degrees, 25 degrees, and the air coming off, generally you want it about 40 degrees plus. What have we got? Oi, 45, 48, 46. I think that's about as much as we really need from out with that lock. Hold the button in and that will disappear back to 0, well, nothing. There we go, up and running. Yeah, what can I say? What better way to spend a Saturday in the rain? Love it.